are all welcome to the 26th Meteorological Virtual Seminar organized by Ghana Meteorological Agency, KNUST, GCRF, African Swift. This is also our first meteorological seminar for the year 2024, and I would like to welcome everybody on board. Today, we will be talking about assessing the contribution of coastal land subsidence to potential sea level rise impacts in data sparse setting. And this case study is over the Volta Delta. We also know that delta are the key systems in the ecosystem, and also the rising impact of coastal settlements has a high impact on delta areas. So this early morning, we'd like to invite Dr. Selassie Yao Avonyo, and also before he kickstarts the whole program, we'd like to congratulate him on his PhD that he received on Tuesday. So please, Doc, you can start with the presentation.
Hello, can you hear me?
Yes, please, you can hear you now.
All right, great. Good morning, everyone, and I'm glad to present to you today, my distinguished audience, on assessing the contribution of land subsidence to potential sea level rise impacts in data sparse settings, the case of Ghana's Volta Delta. So, hello, everyone. My name is Selassie Avonyo, and I'm a postdoc research fellow at the University of Ghana. And I will be presenting on the topic assessing the contribution of coastal land subsidence to potential sea level rise impact in data sparse settings in the case of Ghana's Volta Delta. Now, deltas are essential, generally low-lying coastal features that are predominantly home to a myriad of benefits. And according to Wright in 1977, he defined deltas as coastal accumulations, both subaqueous and subaerial. And what he means by subaqueous and subaerial is that they have components that are below water and then portions that are above water. So both subaqueous and subaerial of river-derived sediments adjacent to or close to the source stream, including the deposits that have been secondarily molded by various marine agents such as waves, currents, and tides. And based on this definition, we could clearly see that there's a complex interplay between some interactions between the riverine system and then the basinal processes. So defining deltas can sometimes be very difficult because they are not cast in stone. But in offering a more simpler definition, Patakaria generally define deltas as a discrete bulge of shoreline formed at the point where a river enters an ocean, sea, lake, lagoon, or other standing body of water. And according to this definition, most deltas are mostly influenced by rivers. Typically, deltas have a subaerial plain where river processes predominate. They also have a delta front, which is the coarser grain area where the river and basinal processes interact. And then the pro-delta, which is mainly muddy. On a global scale, Caldwell et al. 2019 identified 2,174 deltas. And according to their data, there's typically one delta for every 300 kilometers of shoreline. Whereas hotspots such as Southeast Asia have one delta for every 100 kilometers of shoreline. The names of these global deltas are shown in the figure in the lower panel, and that includes Ghana's Volta Delta as well. Albeit constituting only 5% of Earth's land mass, coastal regions, including deltas, produce about 50% of the world's gross domestic product, which is pegged at about 96.5 trillion in 2021 by the World Bank. A host of their diversified services have culminated in higher coastal population, with current estimates exceeding 600 million in or near deltas, especially in mega cities. Coupled with climate change, human interventions due to increasing population are predominantly impacting the sustainable use of coasts and the services they provide. The impacts are exacerbated in deltaic environments, which are already vulnerable to the influence of the sea. Now, deltas are confronted with a far more immediate challenge, and they are incessantly being challenged by immediate threats of subsidence, which is exacerbating prevalent climate change driven coastal hazards. Some studies on coastal areas, such as the Jakarta and the Vietnamese Mekong Delta, report subsidence rates exceeding 21 and 2 centimeters per year, respectively. This provides empirical evidence that subsidence in some areas is outpacing global sea level rise rate of 3.7 millimeters per year. Along with projected sea level rise, subsidence will be responsible for 50% of permanent inundation of deltas by the year 2100. It therefore accentuates the need to continuously monitor subsidence regime, especially in deltas. This is a schematic illustration of how land subsidence occurs. And by way of explaining the phenomenon in simple terms, it is the sinking in of Earth's land mass, which is being represented by the caving section. What are the factors driving land subsidence? And from literature, the drivers have generally been categorized into two groups. That's natural and human-induced drivers, which vary in space or time, and then in terms of their impact as well. Of interest to Ghana's Volta Delta are 3 or 4 hypothesized factors, and they are damming, loading and groundwater extraction, and to some extent, land drainage. Now, to give a brief understanding as to how some of these factors drive subsidence in the coastal delta, we will delve into them one at a time. And for sediment budgets, we'll commence with this short video to explain the concept of longshore drift.
It's all determined by the prevailing wind, the most common wind affecting the beach. And in this diagram here, the prevailing wind is from the southwest. And this means that any waves which come towards the coastline will come in from the southwest. And the effect this has is that the swash of the wave will move the pebble, in this case, up the beach at an angle, and backwash will bring the pebble back down the beach at the right angle. And it's at right angle due to gravity. And the swash will then move the pebble up.
Okay, so having established the concept of longshore drift, we will now delve into what we understand when we talk about sediment budget dynamics. Now, along Ghana's coast, we have the eastward moving longshore drift, which was explained by the previous video. That has to do with how sediment is transported along our coast. And in our subregion, sediment is transported from the west to the east. So the eastward moving longshore drift along the Gulf adds or removes sediment from any given coastal cell, or in other sense, any coastal section along our coast. And the dynamics are such that if the sediment input to a coastal cell is equal to the sediment output, then there's a balanced sediment budget. And so you would have a stable coastline. Now, if you have a sediment input being higher than the sediment output, that the sediment that's been taken out of the cell, which is represented by the size of the arrows, then the sediment budget is positive, and then you would have an accreting coastline. So you have your coastline building and then moving seaward. Should you have the volume of sediment input that's coming into the cell being less than what is being taken out of it, then you would have a negative sediment balance, which would result in an eroding coastline. So having these dynamics in mind gives us a clear indication as to how our coastlines are being affected by sediment budgets inputs by various factors. So having this concept in mind, we look at how sediment starvation influences or exacerbates the impact or the propagation or continuity of subsidence in our local region. So in Ghana's Volta Delta, we have the case of the Akosombo Dam, which feeds the lower Volta Delta with some sediment. And before the dam construction, sediment influx from inland to the coastal areas were estimated to be about 90 million cubic meters. However, after the construction of the dam, it has reduced by about 90% to about 7 million cubic meters. And that is huge since it's going to affect the sediment budget along our coastline with the video in mind. So in this case, you will realize that the amount of sediment coming to the system has been reduced drastically. So you would have an increasing trend of coastline erosion, which is quite evident along our coast with reported cases in literature. Now, moving on to the next driver of subsidence, we look at the extraction of groundwater. And this is a video I sourced from BBC that explains briefly what groundwater extraction is in terms of subsidence. So when you have residents using too much groundwater, especially within a coastal area, the groundwater acts as a bulb or a balloon and over which the land lays. So should you extract the groundwater, you have a deflation, and then the settlements above it would also reduce with time. And should you have these along the coastline, and when the sea level rises, you would have an increase in the water table, causing the flooding of these local areas. So extracting groundwater, especially along the coastline, does not only cause saltwater intrusion, but could also exacerbate the occurrence of subsidence. And of course, this concept is also synonymous to oil and gas extraction. Should you have oil and gas extraction, especially along the coastal areas or in deltas in some places like the Niger Delta, you could have serious cases of land subsidence. Now, moving on to the third driver of subsidence, you look at drainage for land reclamation. Now, sand, silt, clays, and peat make up river delta deposits. And when these alluvial deposits become saturated in wetlands, organic material in the deposit decomposes anaerobically, and the new material builds faster than it decays. However, when when these soil particles or areas are unsaturated or become dry, the organic content, such as peat, oxidize. And the aeration of deposits causes the decomposition of the organic components. And when soils are deprived of the carbon lost in this process, they lose volume and compress, thus resulting in subsidence. The process and subsequent impact of land drainage is illustrated by Engelbrechtsen et al. 2000. And they did this using a pre-development and a post-development schematic illustration. In the pre-development stage, the soil is saturated with water due to the high water table, thus reducing the risk of oxidation or decomposition of organic matter. In the post-development stage, however, draining wetlands can result in the oxidation or decomposition of organic matter in soils and can cause an upsurge in subsidence rates. Wetland drainage for agricultural purposes lowers the water table, creating compaction and aeration of the subsoil. And then following organic material degradation, further volume or elevation loss occurs, which we have in this case replaced with the concept of subsidence. So you realize that areas that were once high due to high water table or saturated wetlands are now reducing in elevation because the water is being sucked out and then it's being exposed to aerobic processes, which is actually breaking down or decomposing this organic matter in these areas, and that's reducing the elevation. And to look at the last possible driver of subsidence within our region, we look at loading. And then in the case of deltas, their surface geology is predominantly covered by alluvial deposits of sand, silt, and clay. And then these soil types are known to naturally compact over time. However, population-driven developments are overburdening the surface geology and are expediting the process of compaction, which is leading to land subsidence in most deltas globally. Having looked at the drivers, we will now look at the general impacts of land subsidence. Land subsidence is synonymous with sea level rise and in most cases mistaken for sea level rise when it comes to their general impact. Subsidence locally amplifies sea level rise and causes devastating impact. And some of these impacts include coastal erosion and shoreline recession, coastal flooding, wetland or cultivated land and biodiversity loss, saline water intrusion and freshwater scarcity, amongst many others. Now, what has been the case of Ghana's coast? Ghana's coast has incessantly been plagued with several coastal hazards. Unfortunately, their occurrences have mostly been attributed to climate change, especially sea level rise. And this is evidenced by the number of local publications on sea level rise rates alone. The most apparent hazards are the perennial coastal floods and erosion incidences as shown by these images. In providing further proof, the projected slide is a real-time drone-captured video of some flooding incidences along Fuveme, a coastal town in the Delta that has extensively been wiped out. These images also show the devastating effects of the surging trend in coastal erosion and shoreline recession. These are also some flooding incidences along the coast of the Volta Delta that have been reported in the media. These reports put numbers to the flooding incidences, that's indicating the number of households and individuals being affected. Unfortunately, the household destruction and human displacements come with cascading impacts, which include the loss of socioeconomic livelihoods as well. To help understand the complexities underpinning the recurrence of these coastal hazards along our coast, we've published the scoping review on coastal subsidence, vulnerability, and sea level rise rates, and by so doing, identify some knowledge and data gaps. In the published scoping review, Figure A summarizes extant literature on 3 selected thematic areas on Ghana's coast, along Ghana's coast. That's sea level rise, vulnerability, subsidence, and their interlinkages. The review generally indicated a limitation in the number of studies carried out, especially in the case of subsidence, which is comparatively understudied. Unlike sea level rise and vulnerability, little is known, however, about the full spatial variability of subsidence, its processes, drivers, rates, and impacts, especially within an African context. Despite these studies, the following knowledge gaps were identified. 1. Publications on sea level rise are mostly based on tidal data that date back to 1970 from Takrady. In the case of Accra, there were some gaps within the data collected, and so it's not effectively being used. So in most cases, they use that from Takrady, which has also truncated at some point. 2, no ground truth subsidence studies have been done along Ghana's coast. The third one being potential drivers of subsidence along Ghana's coast haven't been identified. 4, non-existing coastal vulnerability studies incorporated with ground-validated subsidence. And lastly, there's a huge deficit in available data, and this is a huge challenge because we've been trying to do some models to depict some of the changes or the experiences we are having along our coast, and coming by data has been a huge challenge. And it is something we have to look at critically if we want to take decisions in terms of policies that are backed by science and data. So in an attempt to address the knowledge gaps or data gaps identified in our scoping review, we looked at Ghana's Volta Delta that has incessantly been plagued with coastal hazards, such as predominantly coastal flooding and then erosion. And by so doing, the following research questions were deduced as a guide for our study. 1, is the Volta Delta subsiding? If it is, at what rates? What are the potential drivers of subsidence in Ghana's Volta Delta? And then does subsidence exacerbate projected inundation extents and the vulnerability of the delta to coastal hazards? Having these research questions in mind, we adopted some methodologies. And of course, the study area focused on Ghana's eastern coast, which spans about 140 kilometers from Prom to Aflao, with inland limits determined by a 5-meter elevation contour, which is shown by the red indication in the contour maps. And it also spans an area of about 2,300 square kilometers. There are quite a number of methods available to estimate subsidence, I must say. But then, however, in our case, we used a method called the interferometric synthetic aperture radar, simply put, INSA technique. And then that we validated with ground surveys as since it's a remote sense methodology. And why we use the INSA is because of its high spatial extents, being able to cover areas largely, and then also because of the time scale and the period available. Data has been available since 2015 till date. So you have time series data available, so you can look at trends over time. So that is why we adopted the INSA technique. Now, due to the diversified backgrounds of our distinguished audience, I will be brief on the methodology. And however, should these methods be of interest to anyone, I would ask that you reach out to me and then I'll gladly expatiate further. For subsidence estimation, as I said earlier, we use two geodetic methods. That's the INSA analysis and then the Global Navigation Satellite System surveys. The static surveys were performed in 2009 and 2021 on some 7 ground control points dotted along the coast of the Volta Delta. The static, and these were actually used to validate the remotely sensed INSA results. The sentinels, now to explain the concept of how the methodology works in terms of the remote sensing satellite methodology, the satellite used here is Sentinel. And Sentinel goes around the Earth every 6 days. And at every point, the satellites send radar signals to the Earth. Now, using the University of Ghana campus in this analogy, the satellite arrives. Okay, so assuming this is the University of Ghana campus, the satellite arrives at the University of Ghana campus every 6 days. And once the satellite arrives, it sends radar signals, which then deduces the elevation of the area based on the time it receives the signals that are bounced back from the Earth to the satellite. So it goes round again and returns in 6 days to the same location to send signals again. And should the signals take longer to return than it did the first instance, as clearly seen here, so we realize that the signal here, the distance here was shorter. So it returns to the same location, send the same signals. However, this seems to be longer. So the longer it takes, it relates or interprets that as the area subsiding, that is sinking in. Now, if it takes a shorter time to return, then you have the case of uplift, that is the area is lifting up. So these are the basic concepts driving the use of the INSA technique. In total, we used about 350 satellite images spanning a period from 2016 to 2020. Now, for the estimation of potential relative sea level rise impacts, the simple bathtub method was used due to the data scarcity, as mentioned earlier. And in the absence of high accuracy local elevation data and then the paucity of ground control data, we used Hauser et al.'s digital elevation model that incorporated 2 digital elevation models, namely the FAP DEMs and then the global coastal DEM. The regional sea level rise projections were also obtained from NASA's regional sea level rise projection tool based on IPCC's 6th assessment report. The projections were done up to 2100, with some assumptions being the linearity of the deformation rates and the non-horizontal land movement. Probabilistic projections for the likely range, that's 17th to 83rd percentiles of the sea level rise under both shared socioeconomic pathway scenarios were considered. The shared socioeconomic pathway scenario 2 to 4.5 is characterized by moderate greenhouse gas emissions. And then the shared socioeconomic scenario 5 to 8.5 is characterized by very high greenhouse gas emissions. And these were chosen to ensure that we capture the range of uncertainties. And then the methodology as described in the workflow was used to generate risk exposure maps for sea level rise pathway, which uses only IPCC sea level rise projections And the second pathway, which is the relative sea level rise pathway, uses both the sea level rise and then our locally estimated vertical land motion estimate. Now, onto some preliminary results we've obtained. By calibrating the initial satellite-derived, that's the INSA technique values with the ground surveys estimates that we did, the deformation rates range from subsiding values of minus 9.16 millimeters to uplifting rate of 1.7 millimeters per year. And out of over 11,400 pixels obtained, that's each color-coded point on the map, 99.81% of the total number of pixels indicated subsidence. And the highest subsiding areas were located within the floodplains of the Keta and then the Songor lagoons, as indicated by the blue. Sorry. As indicated by the blue squares, and then along the human influenced Bight of Benin, that's a strip of land separating the sea from the Keta lagoon. And based on the dominance of the subsiding values, the Volta Delta is classified as a subsiding delta. And this is also corroborated by the extensive Holocene deposits in the Volta Delta. And that's deposits that accumulated from 11,700 years ago to the present. About 70% of the surface geology of the delta is covered by alluvial deposits of sand, silt, and clay, which are known to compress with time. And other hypothesized drivers include natural and human-induced oxidation of compressible deposits, groundwater overexploitation, sediment starvation through coastal interventions and river damming, and salt pan dikes and river channel eversions that alter the depositional reach of sediments carrying runoff. Now, the time series plot shows the declining deformation trend for the top 20 most subsiding locations in the delta, with a mean rate of minus 8.67 millimeters per year. The locations, which are not concentrated but rather scattered along various portions of the delta, are defined by a myriad of potential drivers identified. And to single out one of such high subsiding areas is the Keta area. And that I will explain with okay. So in the case of Keta, this slide explains the high rate that was obtained, and the compressibility of alluvial deposit varies with the soil type, with peat being the most compressible soil type, as mentioned earlier. And according to Narine 1998, with the cross-sectional washover terrace at Keta, there is marsh, lagoonal, and then peat sediments underlining the sand barrier. Anthony and Blivi 1999 from borehole samples also corroborate this. And during the Keta Sea Defense Project, Nari and Dibajana 2004 reported that about 200 hectares of land were reclaimed with sediment sourced from the lagoon bed. And there's a possibility that there's ongoing compression of these reclaimed land at Keta due to natural and human-induced loading. That's explaining the comparatively higher survey and inside deformation rates we obtained at Keta. There's also the driver of groundwater over abstraction along the Bight of Benin for varied uses, predominantly for agricultural purposes. And this is lowering the water table, which leads to saltwater intrusion or manifest on the surface as subsidence. And these are some pictures of hand dug out wells and farms I took during my reconnaissance survey, and the repercussions are already apparent. Now, the risk of exposure assessment to map inundation-prone areas within the Volta Delta under both scenarios, as the sea level rise and the relative sea level rise projections pathways are shown in this figure. And as indicated in the methodology, the sea level rise pathway only considered IPCC sea level rise projections, whereas the relative sea level rise pathway takes into account both the IPCC sea level rise projections and subsidence rates obtained in our study. According to these locally improved scenarios, up to 45% of the delta will fall below local sea level by 2100. That's under the relative sea level rise pathway, while that of the sea level rise pathway is estimated at 38%. This was the case for all timelines from 2040 to 2100, meaning that the integration of local vertical land motion data alone increases the exposure extent of the delta by close to 10%, and thus highlights the need for such data for any low-lying coastal area in the delta. Now, the range plots show the extent of delta's exposure under shared socioeconomic scenarios 2.2 to 4.5 in figure B, which is characterized by moderate greenhouse gas emissions, and shared socioeconomic scenario 5 to 8.5 in figure C, which is characterized by very high greenhouse gas emissions. Each plot shows the sea level rise and relative sea level rise for each timeline on the y-axis. In explaining the plot using the 2100 scenarios, it indicates that under the moderate greenhouse gas emission scenario, 18.46% to 28.06% will be below local mean sea level. However, that of the relative sea level rise pathway shows an increase that's to 26.16% to 38.24% by 2100. Similar trends are seen under the very high emission scenario as well. And depending on the climate change scenarios, land subsidence would increase the deltaic area at risk by 96.27 square kilometers to 227.64 square kilometers, and consequently exacerbate its exposure to coastal inundation. Now, one of the greatest challenges, as said earlier, was as researchers is the non-availability, we face as researchers is the non-availability of data or spatiotemporal inadequacies. Thus, in terms of area coverage or period, most available data sets are generally lacking. And in the absence of good data, we explore the use of land cover or land use patterns as a proxy method to establish the relationship between the land cover use patterns and then the land deformation, that's the subsidence values we're obtaining, and how these land use patterns over a given period can act as a driver for land deformation, especially in the vulnerable low-lying coastal areas such as Ghana's Volta Delta. Now, using the FAO land cover classification system tool, we obtained land cover maps for 2001 and 2015, that's spanning a period of 14 years. And you would note that this period, which is 2001 and 2015, is outside the data set for the INSA values, which I stated earlier, that was ranged from 2016 to 2020. And this gap is because it takes the impact of land cover patterns resulting in subsidence is not instantaneous. In classical cases where you have earthquakes, landslides, and sinkholes, you would see that these impacts are instantaneous. You would see them there. But then in this case, where you have drivers such as groundwater extraction, land drainage, loading and all that, it takes years for these things to manifest. And particles, sand particles, soil particles such as clay can take up to 2 decades to show manifestations of subsidence. So that is the intention why, that is the reason behind why we actually gave an overlap between the data sets, a gap between the data sets, so that we can see manifestations of these land use patterns that have been going on for the 14 years. Now, for the 2001 map, a total of 12 classes were obtained, and the most and least dominant classes were cropland and riverine vegetation, respectively. In the case of 2015 as well, there were also 12 classes. Again, the cropland and the riverine vegetation were the most and least dominant as well. And the map achieved an overall accuracy of 90%, which is quite good. The dominance of cropland is corroborated by the economic activity reports of the 2021 population and housing census, which backs our data sets as to why we have cropland occupying larger areas within the Volta Delta. Now, to briefly understand some of these transitions, we use a transition metric showing the percentage of classes that remained unchanged, which is what we are interested in over the 14-year period. It also shows classes that change and what they change to. The color spectrum from dark shades of green to yellow and dark red represents small to large percentage values. The blank spaces show class changes that did not happen. The built-up muddy area and wetland classes lost 0.95%, 1.24%, and then 1.11% of the original area respectively. Now, contrastingly, the water body and the salt pan classes gained the highest with 1.25% and 0.89% respectively. The decline in the built-up class can be ascribed to sea level rise and inland flooding. And then in 2005, Fiatbe's reports estimated that over 70% of the original Keta community alone is submerged under the sea. And this is evident in the recurring news we hear about flooding and storm surges, tidal waves along our Volta Delta. That of muddy area and wetland lost largely to water body, which took 0.98% of their classes respectively by 2015. The salt pan class also took a chunk of the muddy area and water body classes, especially around its bank. Now, Atakwesi 2018 reports an increasing number of concessions being given to large-scale companies to produce salt. And this goes without mentioning the increasing tensions and ownership disputes at Keta and Songor over concessions recently given to Electrichem Ghana Limited for salt production. Now, this is what we are interested in, the areas that remained unchanged over the 14-year period, which was supposed to give us a clear indication as to whether these particular land use patterns are influencing subsidence or not. So the diagonal bold and italicized values represent the area percentages of classes that remain unchanged. It was over these unchanged areas that the satellite-derived rates were overlaid to determine the relationships between land use patterns and subsidence, and then to hypothesize the drivers, since we do not have concrete data or very good data to actually come out with good findings, quantitative findings, I should say. The distribution of satellite-derived deformation rates for each class is shown in Figure A. The highest mean deformation rates, that subsiding rate of minus 1.05 millimeters per year, occurred in salt pan areas. We'll take note of the increasing number of concessions, as I mentioned in the previous slide. So the salt pan areas had the highest number of deformation rates, whereas the least mean rate, minus 0.46 millimeters per year, occurred in built-up areas. In a decreasing order from left to right, Figure B shows the mean subsidence rate of all the classes. And among the classes, salt pan operation contributes largely to the subsidence in the delta. And aside from altering the sediment depositional reach of rivers or surface runoffs due to extensive dikes, there has been reported cases of groundwater extraction for salt production by Atakwesi in 2018. So they do not only have dike systems that act as walls that prevents the runoff, sediments carrying runoff from reaching areas that are already deprived to recompense their losses in elevation, but they also extract, in some cases, also extract groundwater, believing that it has a higher brine concentration, which is good for salt production. And then, although largely considered pristine, some of these land use land cover classes, such as mangroves and wetland, also ranked high. This observation could be ascribed to natural oxidation and loading with limited sediment compensations. A comparison between the land use patterns and the satellite-derived subsidence rates suggested that different land use results in varying subsidence rates, with the highest rate being associated with human influence. And that brings to the fore sometimes our negative, should I say, for lack of a better word, influences on some of the occurrences we do experience, which has a ripple effect on us and socioeconomic livelihood. Now, in terms of projected impact, the most vulnerable areas will be coastal areas that are bounded by both the sea and the two extensive lagoons, that's the Songor and then the Keta Lagoon. And these areas are likely to experience a more rapid rate of inundation. These areas are predicted to experience coastal narrowing. Thus, they are going to receive flooding from the sea and from the riverside, which is landward. And then in locations where there are sea defense walls or revetments, such as Keta, Adan, and Jita, there's going to be an increased rate of coastal squeeze. And this is a phenomenon where you have breakwater systems or defense structures, but because the sea is increasing and then it's squeezing or pushing the land further, the ecosystem within that area is barricaded by the sea defense structure. So it's not able to migrate further inland. So coastal squeeze is going to happen in these areas where you have sea defense structures, and in some cases might lead to the loss of some very important ecosystems. Now, what are the key takeaways of this presentation? One, subsidence is indeed occurring in Ghana's Volta Delta, with deformation rates ranging from minus 9.16 millimeters per year to uplifting rates of minus 1.77 millimeters per year. And then based on the dominance of subsiding persistent scatterers or pixels, and then the survey rates that actually validated these satellite-derived values, the Volta Delta can be categorized as a subsiding delta. And then some of the most subsiding areas were the floodplains or the banks of the Keta and then the Songor lagoons. The relative sea level rise impact assessment for both scenarios, that is the shared socioeconomic pathway scenarios for intermediate greenhouse gas emissions and then the very high greenhouse gas emissions, do suggest a substantial increase in exposure even in the near term. Land subsidence is projected to increase the extent of exposure by almost 10%, with values ranging between 96.27 square kilometers to 227.64 square kilometers. And then that is depending on the scenario we will be looking at. Now, these findings therefore accentuate the need to implement monitoring measures to store the impending threat subsidence poses to the sustainable use of the Volta Delta. And these measures must first include monitoring of the hypothesized drivers to understand the phenomenon's complexity before putting in mitigative measures and then involving relevant stakeholders as well. These are some of the references I use for my presentation. And then thank you for listening.
Thank you, Doc. This was a very insightful presentation, and I would like to open the floor for questions. But before I open the floor for questions, Dr. Selassie Avonyo is with the University of Ghana in the Department of Marine and Fisheries Science. And he's also endowed with knowledge about coastal processes, physical oceanography, climate change, environmental impact assessment, and also water quality assessment. For questioning. So please, if we have any question, we can raise our hands and ask, or we can also type it in the chat box. So we ask Dr. Selassie. But before anybody does that, Doc, please, I have some few questions for you.
Okay.
So the first one will deal with the Sakumono wetland. When we take the situation of the Sakumono wetland along the beach road at Tema, you realize there was supposed to be a wetland, but there has been a lot of developmental projects on that area, and also there's been a projection of a sea defense. So I wanted to ask that, is in the long term, is there going to be a coastal flood along those areas, since there might be a sinking of land due to infrastructure developments?
Yes, so it's as indicated in my presentation, is one of the major drivers of subsidence in coastal regions. And basically Sakumono is also predominantly covered, the surface geology of it is predominantly covered with alluvial deposits. So you possibly have a lot of silt, clay, and all those things. So if you tend to build on these areas with time, there's going to be significant compaction. And of course, with the increasing sea level rise, these areas stand a huge risk of being inundated in the future if measures are not put in place. So in actual sense, I am working on that area across Accra to Sakumono, and some preliminary results are also indicating high rates of subsidence within that region as well. So yes, to answer your question, these areas are vulnerable, and developmental projects ongoing there must be done. I don't know, probably they should consider a lot of things before they put up such structures in those areas. Yeah.
Oh, okay. Thank you. Please, my second question, depending on your presentation on coastal flooding. I wanted to ask that, is it as a result of climate change, I mean, it's increasing the volume of the sea rise, or is as a result of the sinking of the land surfaces around those areas?
Yeah, so as clearly indicated in my presentation, I had two scenarios which I used for the projections. And one of the scenarios was sea level rise only, where I looked at how sea level rise projections up to 2100 will influence coastal areas. And then the second scenario was a combination of relative sea level rise, which is a combination of sea level rise and then subsidence estimation. And of course, clearly sea level rise on its own, the projections are that is going to increase the areas that are going to be inundated in the delta by 38%. So 38% of the delta will be inundated by 2100 by just considering the sea level rise alone. Now, if you bring in subsidence, which was overlaid on the sea level rise projections as well, that is also going to increase the rates from 38 to 45%. So yes, sea level rise on its own is going to cause havoc, but if you add subsidence, it's going to expedite the process and then the areas that are going to be affected. So both ways, there are issues there. But then again, we would have to do everything within our best possible to mitigate our parts leading to subsidence and allow nature take its course, which is inevitable.
Okay, so to add up to this question, I'm going to use the concept of the we were talking about when there's going to be a positive deposit into the coastal area. So let's say if there are positive deposits or continuous deposits of sediments into the coastal areas, or let's say the coastal lands, and there's even a high increase in sea level, is there a probability that there will still be no flood since there's been an increase in sediment deposition?
Yes, so the coastal area elevation is a balance between sediment influx from inland and then, of course, longshore drifts along the coast. Now, if the sediment balance, as I mentioned in my schematic illustration about the sediment dynamics, if you have a lot of sediments coming into the system, the beach builds up, it accretes, and that accretes both in elevation and in terms of extent longitudinally. So if your sediment influx is more, you are likely to, I wouldn't say, I'm not going to say it's going to affect the occurrence of flooding, but it would probably delay its occurrence or extent of damage. Do you get it? So sea level rise will take its course anyway, but the amount of sediments building up at the coast, which is going to affect the elevation of the near shore area, plays a significant role as well. And then also determines how the back beach or inhabitants at the back of the beach, or in this case, along the Bight of Benin, are going to be protected. So they are all very important factors to consider in the fight against climate change.
Oh, okay. Thank you very much. So please, the floor is open for questions. You can raise your hand so we read the questions, or you can type it in the chat box so we read that one to you.
Hello, Doc.
Hello.
Hello, Doc.
Yeah, hello.
Hello, please, you can ask your question.
Thank you for the presentation.
Thank you.
Concerning the Sakumana.
Okay.
Yes, one can still see that the land is even chopped to create roots and other things which is in between.
Sorry, you are not audible. I don't, if you can, your voice sound a bit muffled.
Okay. Can you hear me clear now?
Please go ahead.
Okay, so what I'm saying is that the road at the Sakumana is they are keeping chopping the road, so they are keeping chopping the land to create roots, which is fairly in between the sea and the internal waters. So what are the effects of those that activity? Let's take an example from the what's the name? Barrier to the Tama port. There's a new port that is created. You see, that road the land is chopped. It's even chopping down further. And then we have the internal water, and then the sea, which means that the road is in between. And then right now we are talking about the higher rise of the sea level. So anytime that the internal water rises and the sea water also rises, what are the effects of that particular area?
I honestly, I struggle to hear everything you said, but let me try and answer anyway. So
Okay,
clearly,
so let me put it again. What I'm trying to say is that right now, the land at the Sakumana beach. So if you are going to Tema, on your right, that is the sea, and on your left, that is the internal water. At least that is the wetland.
Yeah.
Okay, and then in between is the land which is chopping deeper down to create a route for vehicles.
Okay.
So what are the effects? What are the effects of that for the future?
So in fact the road in itself, I mean, this is quite a dynamic approach. I mean, the sea level would rise anyway. It's just as to the extent of damage it would have on the areas beyond the road. And if I get your question clearly, definitely if you have inland waters rising and you have the sea level rising, it's going to have significant impacts and then extend the flooded areas in the near future. So the road, I mean, it depends. So it's very dynamic. The sluice. So you realize that the connection between the sea to the Sakumono area has a semi-closed sluice. So based on the aperture of the sluice, that will determine the amount of water coming into the Sakumono Lagoon area. And so many other factors. It's something that has to be modeled to completely understand what might happen. I wouldn't be able to actually tell you projections by just using my thoughts. It's something that we have to consider, use certain environmental variables and parameters to do some projections that may be sort of synonymous to what we are expected to have in the near future. So until such studies are done, I wouldn't preempt myself to give such predictions. But definitely, when you have sea level rising and you have inland water rising, you are definitely going to have increased flooding incidences.
Yeah, thank you for that one. And then my second question is about the human activities of digging, maybe creating a particular hose in order to get water for irrigation. And then the escape of salt into that water, that activity. So what will be the effect of those agri activities at that particular area?
Yes, so if in my presentation I played a video that shows how extracting groundwater, and not just groundwater, even oil and gas production, hydrocarbon extraction, is going to affect the land elevation. So to give a very simple analogy, just picture an inflated balloon over which you have placed, let's say, a book. Now your inflated balloon, in this case, represents your water that is below the earth, that is within the earth. Now, if you suck out the water, in this case, you release air from the balloon, you realize that the balloon would deflate and shrink and lower. In the same way, when you have the land overlying these areas that have water, the more you take water out of the system, which in this case is acting as an inflated balloon, to give a simple analogy, the water table is going to reduce and lower. And so will the overlying land above it. So the land above it, as the water table reduces, the land above it also reduces. So excessively taking water from especially coastal areas does have some significant impact on the elevation, and in this case, land subsidence. So yes, over extraction, over exploitation of groundwater in the long term will drive subsidence in coastal areas. So I mean, it's something that we, like I said, data sparsity. We do not have a lot of data. Ideally, we should have an idea of recharge rates into our aquifer system, underground system, how much water is coming into the system, how much water inhabitants are extracting, so that we have a fair idea of how to balance the extraction as against the recharge, so that we know that our water table is not going to reduce. So these things, I mean, it offers opportunities for us to do more research to understand the complexities of these areas.
Okay. Yeah, thank you, Dr. That. My third question, sir. Doc, right now, you did indicate that the coastal land is shrinking. So,
Yes.
Doc, in future, are we losing our beaches for sea defense?
Well, I mean, that has already been established in literature. There have been reported cases of high erosion, and this is even beyond the scope of subsidence, just coastal erosion. There have been some significant works done by Professor Kwesi Appiah-Nenado, Jason Kwashigan, Brimpong, Donatus Anuring. A couple of literature is available out there to indicate the high rates of erosion along our beaches. So yes, some places are losing their beaches, whilst some places are creating or gaining more. So it's a complex situation, yes.
Okay, Doc. Thank you for that. I don't know whether, are you familiar with La Palm Beach?
No, I haven't done any work there yet.
Okay. Okay. So from the La Palm Beach going to the Bush Road, there's a bridge in between there which connects the lagoon to the sea.
I see.
And if one observes, the sea level is rather the land is let me say the land is below the sea level, and then
I see.
artificially they are trying to create a channel which the lagoon water can enter into the sea. But in that process, they are rather making a mistake for the sea water to inflate in the lagoon.
Okay.
So I don't know, maybe at your level time, you can also walk through there. Then at least maybe you can have advice, and then people can have discuss about it, because it will be a disturbance if the sea level walk in the lagoon. I think that place it will not be a good what's the name habit way for the humanity.
Duly noted, sir. I've taken note of it.
Thank you,
Right.
Doc.
Thank you very much, Mr. Safianu. And thank you, Doc, for the explanation. Please, there are some few questions in the question box I would like to read out to you.
Okay.
Please, Estado is asking that the Keta case, was it due to a natural cause or as a result of human activities?
Yes, so I stated in the presentation again, it's largely due to human activities, which is why I did the land use land cover thing, which clearly showed human influences through cases such as salt pan operations. And then, of course, the Akosombo Dam as well has reduced sediment fluxes to the coast by about 90%, which naturally would have recompensed the losses in elevation along our coast due to erosion or natural compaction. So yes, largely human influences are playing a key role, but then we can't completely negate the natural ones as well. It's definitely playing a role, but the human influences are much more larger in terms of impact.
Okay, thank you very much. I hope Esther's question is being answered. Also in the chat box, somebody is asking, what is the influence of the port expansion on the delta and its ecosystem?
What's the influence of the port expansion on the delta and its ecosystem?
Yes, port
So,
expansion on
yeah.
delta.
Yes. So indicated in my presentation again, we have an eastward moving longshore drifts. Along the Gulf of Guinea, our waves, our currents, they move eastward. So from west to east. Now, here's a case you have the port with a breakwater system extended into the sea. So now it's going to interrupt the movement of sediments from the east and from the west to the east. And the Volta Delta is to the east of the port area. Now, if you have these sediments being reduced and not reaching these areas that are already also experiencing erosion, that means these areas are going to, and again to the dynamics, if the amount of sediments coming into the system is lesser than the amount of sediment leaving the system, they are going to have cases of erosion. So, I mean, I know there are ongoing environmental impact assessment studies going on for the port expansion project and all that. I'm yet to see the actual findings completely, but definitely when you have breakwater systems on the leeward side of a vulnerable coastline, you are bound to have more erosion in those areas because those areas are going to be deprived of sediments reaching them. So yes, to some extent it would.
Okay, thank you very much. Please, we have a hands raised from Mr. Hayford. Please, you can unmute yourself and ask your question.
All right, thank you very much. Doc, thank you for your presentation. Considering the fact that population is increasing and then the issue of global warming cannot be stopped, how do we mitigate against this coastal inundation? Is it the case that coastal areas should be freed from all infrastructural activities, farmlands, salt pans, and all those things? How do we mitigate the effect of coastal inundation, Doc? Thank you.
Yeah, so by way of recommendation, I think we will start off from the identified or hypothesized drivers, and one of them is classically the groundwater extraction. Now, if we drive along the Bight of Benin from Anglongan to Aflao, that stretch, I mean, you would see a lot of farmlands that are heavily dependent on groundwater for irrigation purposes. I mean, so these are some of the drivers of subsidence. So first off, we have to find alternative and more renewable sources of water rather than relying on groundwater, which in the long term can affect subsidence. Okay. Now, I mean, that also transcends to hydrocarbon extraction. And recently we have the case of, I mean, this is a very controversial recommendation, but we have a case of the Volta Basin being explored for possible occurrence of oil and gas, hydrocarbons. I mean, should we go ahead and exploit these resources within the Volta Basin, which is already vulnerable, then we are likely to exacerbate the situation and cause more havoc. So we should find alternative energy sources and freshwater sources to supplement what we have already. Now, in the case of for instance, the hydrocarbon, the Akosombo Dam that is affecting or reducing the sediment influxes. We need to get a more regulated flow to allow sediment, or probably a bypass to allow sediments to reach these coastal areas that are being deprived of the sediment. And that is a whole engineering concept that has to be done. I leave that to the experts. The other thing we could also look at, I mean, quite a number, but these are the two most prominent ones. Of course, salt production, relying on groundwater. You could also have a desalination process so that, I mean, brine production on the side so that people don't have to rely on groundwater for brine production to produce salt. A couple of other mitigative measures that can be put in place.
Thank you very much. I think it's okay. Thank you.
All right. Thank you very much, Doc. Please, there's another question in the chat box. And the person is asking, is there a reason why some lagoons are not allowed to flow freely into the sea, or the sea is not allowed to influx into some of the lagoons?
I don't think that's the case. Naturally, lagoons would empty into the sea at some point. I don't think it's, of course, when you have high tides, the sea moves further inland, but once it recedes, I mean, you would have the natural flow happening. Lagoons would always empty into the sea, so are estuaries. So it's not a case of lagoons not being allowed to enter into the sea. That attaches some sort of mysticism to it. But clearly, lagoons will always enter into the sea, whether closed or semi-closed. And then the sea intermittently comes inland when there are high tides, or in this case, long-term projections of sea level rise.
All right. Thank you very much, Doc. Please, we are so open for questions. Hello, bro. So before another question comes in, I would like to ask this one, and this one is about the policy making. So,
Yeah.
as from what you've done so far, most of the times there will be science write-ups with policies, but the policies are not made effective. So I'd want to ask, how can we make policies from what you've done very effective?
Hello, Daniel.
Yeah, hello, Doc.
Yes, I didn't get what you said. I think my internet dropped a bit.
Oh, all right. So I was asking about the policies, the findings you've done. Most of the times
Mhm.
with science findings, we will be done with everything, but the policies are not being implemented. So I was asking, how can we go about the policies with respect to what you've done and how it's going to be implemented to save the coastal areas or the deltas in the Volta Basin?
Yeah, I mean that's one of the most difficult challenges we face as researchers. We do all the work and then it ends up on the shelf. So I mean, doing this presentation, for instance, is a good start off point to put it out there, let people be more aware of the occurrence of subsidence, which is almost unknown in our subregion. So avenues like this, workshops, conferences, we try to make noise about it as much as possible. In terms of the policy components, we may have to put in some measures, extra harder, go beyond what we normally do, and try to bring some policymakers to the fold when we meet them in some gatherings, and I mean, put out our findings in a very simple way so that they can appreciate what we do, and we'll see what will come out of it. I'm afraid I'm not able to say much because it's been a huge challenge. We may have to readapt and come out with better solutions that can bridge this gap between science and then policy implementation.
Okay, sure. Thank you very much, bro. So please, we are still open for questions. If anybody has a question, you can type it in the chat box or just raise an. Okay, sorry, there's a hands up. Mr. E3 Mate, please, you can ask your question by unmuting yourself first.
Okay, thank you very much, Brother Daniel, and good morning to everyone on the platform. Unfortunately, I couldn't join on time, so I may not have been privy to most of the information discussed or relayed earlier. However, my little question has to do with the, since it has to do with, how do you call it, the sea and the land. I wanted to ask the impact, the long-term effect of the salt mining that is from the Songor Lagoon at Ada, the long-term effect of it, whether being its positive or negative impact in the long term. Doc, thank you.
Yeah. So again, from my presentation, sorry you couldn't join from the beginning. I stated that the salt mining has two major impacts or effects or drive or modes for which they drive subsidence. Now they have the salt pan dike system, which is elevated areas around the salt pans to contain the water. Now, when you have these dike systems over huge expanse of areas, naturally, when you have runoff, when the rain falls, let me put it in a very simple term, like when the rain falls, it carries a lot of sediments south to the coast. Now, when they reach these areas and you have these dike systems which act as walls, naturally it would prevent the deposition of sediment in these areas. So if these areas are already experiencing subsidence, in a very natural environment, these reductions are going to be recompensed by the sediment that is coming in from the top. But since these sediments are being blocked from reaching these areas, they are going to continuously experience subsidence and not be recompensed with the sediment. That is one. Two, in some reported instances where I stated that some companies have been reported to extract groundwater for salt production because these groundwater within the groundwater within some of these coastal locations have higher brine concentration. And when you have high brine concentration, that means you're going to get a lot of salt from production. So some of them are heavily reliant on groundwater for their salt production, which in the long term, again, brings us back to the video I talked about that is going to reduce the balloon in terms of elevation and the land above it, which is also going to sink down. So yes, it has this long-term impact. Then again, it's not to say that people's livelihood should be taken from them. You should look at some of the more practical and sustainable ways to to exploit all these resources, which are very relevant to people's socioeconomic livelihoods. Thank you.
All right, thank you very much, Doc. Please are still waiting for questions. We have some few minutes to end the meeting, so please, if there are extra questions, you can raise your hands or type it in the chat box so I read it to you. Hello, Doc.
Yes, I'm here.
So please, with respect to, let's say, mining cases of late in Ghana, the illegal mining that has endangered lots of our river bodies, would it be advisable if you still, let's say, mine for groundwater for a large scale production, or is going to affect the ecosystem around areas?
Can you come again?
So with respect to the illegal mining issues of late being on a rise in Ghana, and our river bodies being affected by such activities, is it good that we still go in for underground water, or it is going to affect the coastal areas, or let's say it's going to cause a deflation in the land?
Of course, I mean, the discussion we've had all this while has been centered along the coastal area, and that has been the focus of it. Now, with regards to illegal mining, which is further up inland, the influences of the sea may not get to this point. So that is out of question. Now, beyond the scope of this presentation, is an established fact that illegal mining is having, I mean, a huge impact negatively on ecosystems and all that. So I'm not in any way going to in any way condone the continuation of it. So in every shape or form, I think some measures have to be, if in case there are measures, I mean, these measures have to be upscaled to mitigate or stop these illegal mining activities, which may or may not have direct impact on the coastal areas.
All right, thank you very much. These are still open for questions.
Hello, Doc.
Yeah.
This is Sofiane again. Doc, the introduction of the blue economy, what will be the benefit? The depletion of the coastal land.
In your introduction to the blue economy, I didn't get that.
Yes, what I'm saying is that the introduction of the blue economy.
Okay.
What will be the benefit, the depletion of the coastal land?
What will be the benefit of a depletion to the coastal land?
Yes.
I'm not sure I get your question correctly.
Okay, so what I'm trying to say is that the coastal land is shrinking now because of the sea level is dropping in. So the blue economy is simple to at least harvest what is from our sea for the social lifestyle of the humanity. So right now that is, can we harvest what is the sea to take care of the shrinking of the coastal area? That's what I was trying to. That's the question I wanted to ask.
I don't know. I don't know if I'm getting you correctly.
Okay.
But
so, the blue economy, the introduction of the blue economy is the activities that will carry on through the sea. And once those activities are carried on, the sea also expands to chop in the remaining coastal land. So the sea becomes the mechanism to protect the land. Whatever that we are harvesting of the sea, can we use that to help protect the remaining land that is by the sea?
I mean, okay. So maybe I'm not getting, but the point is that the blue economy is an entirely different concept on its own. Coastal subsidence may not directly be synonymous or feed into the blue economy in its generality. Now, I'll say that if I understand your question correctly, because I'm still trying to understand how you put your question, you can't recompense whatever it is that is happening on the land based off of what you are getting on the sea. You would want to actually address what is driving these occurrences on the land, first of all, before you look at any other thing. So the first point of attention should be what is driving subsidence along our coast. And these are human influences on the land. You get it? So that is what has to be looked at first before any other concepts or any other ideas can be brought to the fore. So sorry if I didn't get your question correctly, but I don't know. I'm just trying to answer based off the little I had.
Okay, but okay, let me translate it further. In
Yeah.
Ghana here,
Hello, Mr. Safianu.
yes,
Hello.
sir.
Yeah,
Yeah,
so
I
I
can hear you,
think
sir.
I think you would have to type because there's a difficulty in getting the clarity of your voice. Or more, I think you can also take off the headsets and actually using the phone's mouthpiece. That would be far better a little.
Oh, okay.
Hello, Doc.
Yes.
Now,
Yes.
okay. So what I was trying to say is that the introduction of the blue economy can it have a positive effect on the shrinking coastal land? Example, Ghana, some years back, Ghana wanted to introduce the marine drive. Introduce the marine drive, it will carry a project whereby settlement will be put in at the coastal lands near to the sea, which they can be receiving the human activity from the sea to the land. In that manner, as we say, we'll create a particular places where we can take water from to even to build those kind of structures to admin the activities of the marine drive. And what I'm saying is that right now, so the blue economy can you have a positive effect that at least maybe whatever that we are harvesting on the sea can be used to create at least those areas that are shrinking inside, like the Keta sea defense and the other, as you explained in your presentation.
Okay. So blue economy always has or would largely have a positive influence on whatever it's would largely have a positive influence. Now, if you say that they would extract certain I don't know if you mean by what do you mean by that, indicating that you would extract probably sand or sediments to recompense elevation being lost on land to beef up or increase elevation. If that's what you mean, then yes. In classical cases of port expansion projects or port development, there's a lot of dredging on land in the sea to build up these ports in terms of elevation or area. So yes, some of these things can be considered. But then again, I would still come back. Of course, there's beach nourishment globally in advanced countries where they scoop sediments from the sea to nourish the beaches to have what you call the natural motto. So that's something that can be done. However, we have to first look at the drivers that have been identified based on the hypothesized indications we've given, and then address them from that angle. Then we can look at the much more expensive or long-term plans, like what you are suggesting through the blue economy. So yes, it's possible.
No, okay. Thank you, Doc.
You're welcome.
All right, thank you very much. So also soon we would like to bring the seminar to an end. And before we actually end the meeting, I would like everybody to turn on their cameras so that we take a picture of the participants. Then we move on to end it. So please, can we all turn our cameras on? All right, so on the count of three, we'll take the first shot, then we'll do it for the second time. Then we close the meeting. So 1, 2, 3. All right, we take the second one. 1, 2, 3. All right. Thank you very much for joining. And please, the video will be made available to those who registered for the program. And please, our next meeting is going to be in February. Please endeavor to register so that you can have the video after that one too. Thank you very much. And we'd like to congratulate Doc again on bagging a PhD. Thank you very much for everyone who joined, and have a blessed day.
All right. Thank you very much, Daniel, and thanks for having me.
Thank you.